So my name is Rob Barreras. I'm with the county Office of Emergency Management. That's in the Chief Executive Office. I'm an emergency management coordinator. With that, I oversee a lot of the IT stack for the Office of Emergency Management. Two components of that kind of come together this afternoon, and it's really a pleasure to speak at GIS Day because this is really the intersect of a couple different technologies, from public alert and warning to IT with app development, and then rounding it out with GIS capability as another IT component for this automation. And one of the things that I'll share is one of my mentors from a long time ago. He kind of taught me and saw us doing similar regular standard routines over and over and over. And in emergency management, when seconds matter and you have limited resources and staff, a lot of the time it's best to automate as much as possible to take out as many clicks and steps as you can. So I was really privileged to work with the team member that I have a pleasure of presenting with today, Tom Weisenberger, as well as some great ISD application developers. Sun Lee, I'd be remiss without mentioning him during this presentation as well, to kind of take this vision and turn it into a reality. So what we're going to take a couple minutes and talk about is IPAWS, and many of you may not know what that is, but by the end of the presentation you will. And the application that we developed is called IPAWS Aware, because we want to gain situational awareness. So that's why the title of this presentation is Modern GIS for Enhanced Situational Awareness for Public Alert and Warning. So those are kind of those mass notifications that you might receive during an emergency. Get this to go forward. There we go. One more. So what is IPAWS? So IPAWS is a federal program. It stands for Integrated Public Alert and Warning System. Many of you have received these messages before. Wireless emergency alerts, those are those 360 or 90 character messages that you get on your smartphone. Then you have that emergency alert system, whether you're driving your car or watching TV, you know, beep, 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 this is a test of this system. Had this been a real emergency, public safety would have told you what to do afterwards. Or even those NOAA weather radios. So if you have one of those will go off for the National Weather Service. So any weather warnings, watches, advisories, you can be aware of those. And IPAWS is actually 10 years old. I had the privilege of doing their second user conference a couple weeks ago, to also share with them IPAWS Aware, since it's kind of cutting edge for the space that we're in right now. To give you just a little background for the County of Los Angeles, so the alert and warning program that I oversee the technology of, we have a plethora of capabilities. So that could be like law enforcement doing field notifications, so door knocks. We have websites and social media. It's very easy for us to tweet out. But what happens when we need to do hundreds of door knocks in a very limited amount of time? You know, we have emergency mass notification tools for that. So reverse 911, we have a database with over 2 million records in it that are all geocoded. And with that, I can go draw a polygon and call via voice, text, and email those individuals. That's very precise. Next rung up, we have WEA, Wireless Emergency Alerts, and NWEM. So those are those wireless mobile text messages, or also those weather radios. And then EAS is the tip of the spear. Very important for us. Anytime we go to one level in this pyramid, we're always doing everything underneath it. What we'll talk about today is wireless emergency alerts specifically. And why do we talk about them? Well, everybody typically has a mobile device. So a lot of the time we would hold campaigns and try to get people to register for our mass notification system. Well, now with a modern mobile device, and these kind of started rolling out in 2012, so not very common for any of us to have a device that's over 10 years old. So more than likely your device is WEA capable. You don't need to register for it. I already have your information, and if I draw a polygon over an affected area, you would get broadcasted that message in either a 30 or 90 or 360 character message, and in English or Spanish now as well. And as WEA 3.0 got launched in 2019, it's getting more geographically specific and accurate, so that geofence around that notification area, it's getting really precise. With currently around, in 2022, this number just came out last month, around 60% of mobile devices are WEA 3.0 capable. So what that means is by 2023, 2024, we'll be in the realm of 80, 90%, and really hitting it to where this 1/10 of a mile accuracy is going to mean that more individuals, more cities, more alerting authorities, more jurisdictions are going to use a WEA first approach for notifying their residents. So how do we monitor all of these WEA notifications as they're going out? And that's kind of what we'll talk through. Why did we have to do this? Well, the County of Los Angeles is extremely complex. We have 88 cities. Of those 88 cities, 27 are actually IPAWS alerting authorities. When they become an IPAWS alerting authority, they don't become a sub-level of that area. They also they get access to the whole county, the full FIPS code. And when they have access to the full FIPS code, that means that even though the city of LA may only notify within the city of LA, they actually have access to notifying outside of the city of LA as well. So we kind of coordinate with them before to make sure that they stick to their geographic boundaries. However, that becomes complicated because there's some GIS limitations to 100 nodes per, so 100 vertices per shapefile, and a maximum of 10 shapes, and a maximum of 100 vertices in any one notification. Why does this add complexity? So for all those devices that aren't 3.0 or 1.0 or 2.0, some of the bleed over, the spillover, the extra from that geofence can be up to 10 miles. So a city like Pasadena may only notify the city of Pasadena, but that might actually go out much broader, the areas around the city of Pasadena, with those older devices. And because of that, we want to make sure that we're having the one voice for alert and warning and emergency public information to make sure that residents know exactly the public, the safety measures that they should take to ensure that themselves and their families are safe. So how do we monitor for all of these 27 alerting authorities when something may go out? Well, that's why we developed IPAWS Aware. So we saw a need. How we have 27 alerting authorities that may send out WEA messages at any given time. And we want to have situational awareness of when those messages go out, so we understand who our residents that may be impacted are throughout the whole county. With that, that brought us the challenge. And the solution ended up being partnering with FEMA, so the Federal Emergency Management Agency, to become a IPAWS application developer. Once we became an application developer, they provided us a REST service that we can monitor, to actually, which is the IPAWS Open Atom Feed. I shouldn't have said REST service, it's the IPAWS Open Atom Feed. And we monitor that every 15 seconds for new alerts that go out on the platform. Once we have that new alert, it gets added into a database, which then runs through scripts, and then we can email the stakeholders. As many of us know, an email is a powerful thing to get engaged. Like, hey, it's one thing to log into a system and see what's going on, or it's another thing to go to PBS Warn, but I might need to hit refresh to see what's new. It's another thing when I get a notification that tells me there's something that's going on and I need to start focusing on that. So we built this out. It provides a couple different GIS products that I'll go over really quickly, but now we are also in a phase where we're conducting this at a California Statewide Pilot Program. So for the 58 counties, we are actually sending this to the California State Warning Center, and from there, they are sending it out to the counties. The OAEOC Technology Hub is the application that kind of pulls this all together. So I'm highlighting the IPAWS Aware. I'm showing one that was actually received today for a silver alert. That's kind of a missing elderly person. And then on this top, you see where we have everybody. So the FIPS code and the Atom feed, it's actually for the whole nation. So there's discussion from FEMA, and the state of California is trying to adopt it and take it over for the state. But there's also discussions with FEMA to see how we roll this out nationally. And then easy subscription front end to where I would go into one of the operational areas, one of the FIPS codes, and then just add somebody's email, and then they would get the notifications. Other piece that we needed to do to make this work is we needed to partner with Esri. So many of you know business analysts, and many of you may not know the evolution of business analysts. So Business Analysts Online was a product where you would need to log in and then run the reports or the infographics directly from that online platform. Later on, they developed a web app builder widget. However, you would have needed to log in to that web app builder app to actually run that report. One of the things that we were able to do to make IPAWS Aware actually come to life is through a partnership with Esri. They added the API automation of the Esri business analyst, so we can just call and run those reports on demand without needing to log in. And prior to IPAWS Aware, this capability did not exist under the Esri platform. They helped us build this in. They understood our use case. And once again, I'd be remiss if I did not thank the Esri partners for making that happen. The automated email that goes out about 30 seconds to a minute after that notification, 15-second interval for finding new alerts looks like this. It has the 3 attachments as an image, a shapefile, and then the infographic as a PDF. That's a kind of a close-up of the image. Why do we get the shapefile? Because many of us have public-facing emergency maps, and now with the shapefile, our GIS team doesn't need to redraw, retrace, re-geocode anything. They just can take the shapefile, drop it onto the map, run the script, and get it up and out to our public emergency map. Here's the size up for emergency managers. So we get an infographic. So it's one thing to know a geographical area about where something's impacted. However, now I get a size up. What's the daytime population? What's the nighttime population? How many businesses? How many individuals may have access and functional needs? What's the demographics? What's the socioeconomic impact? From there, our sheltering teams, our public information officers can start moving forward to ensure that we are communicating effectively with the individuals in the impacted area. And with that, for the GIS take, I'm going to turn it over to Tom Weisenberger, the individual that coded and really helped build out those GIS products that I just went over. Tom.
All right, thanks, Rob. And thanks to everyone for sticking it out here till the very end. Hopefully this will be quick. So my name is Tom Weisenberger, GIS specialist, ISD Enterprise GIS Group here at the County of Los Angeles. And I'll briefly touch on some of the more technical GIS work running in the background of IPAWS. So the challenge we had to face with this when Rob approached me with coming up with a solution here is that how to create and provide access to GIS products for an alerting system that only contains text-based geographic information. So this includes details about the alert, the message itself, the type, the time it came in, etc., plus the location, as seen here on the slide. FIPS code is a unique county ID, is for mostly weather events covering a large area. Circles are being alerted for point proximities, such as a silver alert that Rob mentioned earlier. And then polygons, we also need to handle for specific areas that may be threatened by a fire or flash flood. So web services offer a unique way to provide solutions for users to remotely execute complex Python scripts through a URL or simple button execution. There is some configuration involved on the web server to execute the scripts. And in some cases, they need to be run as a specific user that has an ArcGIS license checked out for ArcPy. Simple requests can be made through a URL with the query string parameters being passed into the script. That's what makes them reusable, and especially powerful. So we've been able to use these web service scripts quite effectively to remotely execute data updates for the public emergency map in order to extract, package, and upload the features to ArcGIS Online from the Emergency Operations Center's enterprise geodatabases. Next slide. So the IPAWS GIS process, this is what worked for us. Certainly there are other ways to do this. However, this approach is what we were able to work out fairly quickly and easily to accomplish the tasks for this system. First off, IPAWS app detects a new alert that's come in. As Rob mentioned, it's checked every 15 seconds. And then it remotely executes the GIS script through a web service, passing in the alert ID. The script takes that alert ID and then calls back to IPAWS to one of its web services to get the detailed JSON data back for the alert. So the script logically breaks out and processes the geometry text information into a geodatabase and creates the map and report products. So ultimately, the 3 GIS products are placed into a web folder that the IPAWS application has access to, and each file is named with the alert ID. So this uses both the ArcPy to generate the map and shapefile, and then also the ArcGIS Web API for Python for the report and infographic. So next slide. So the script is built to handle 3 different geographic areas, types, as I mentioned earlier. Polygons come through as coordinate pairs separated by a comma and a space between the pairs, creating a complete polygon loop. Circles come through as a point coordinate pair along with a radius in miles. And then the FIPS codes come through as a single county FIPS or a comma separated list of counties affected. Since county geometry is already known and it's not actually being provided through the alert, it's pulled from a geodatabase feature class of counties with FIPS codes in them. And then there's 3 different map products that are generated by the script. The map is very simple, but it could be more complex with graphics, dynamic data elements, or it could be exported in different formats. The data is a simple shapefile export where output files are packaged into a zip file using Python. And then a report is generated using ArcGIS Online Web API for geo-enrichment and infographics. Next slide. So creating a map, this is fairly basic. ArcPy, first design the map layout. You can either do it in ArcMap or ArcGIS Pro. Add the data layer that is being actively updated with new features. And then through the script, set a definition query on the layer, update the map extent, and then export the map to whatever preferred format you like. So in the view here, you're seeing all the alerts without any filters on them. Next slide. And then I'm not going to touch on creating the shapefile. There's not much to it. It's basically feature class to feature class conversion and then using in built-in Python zip module to package the files. So for creating the report, Rob handled the report template design and then provided me with the report ID. And it's the polygon, the circle, or the county boundary is converted into a text string. It's referred to as a study area in order to be called to the web API through Python. So credits, I believe it's about 10 reports per dollar in credits. So there's quite a bit to this. There's a link here below if you're interested. So there's quite a few other geo-enrichment tasks, not just business analyst reports, and then also the ability to create infographic reports. And that should wrap it up.